Another feature that is supported with SC3 is CORS, Cross-Origin Resource Sharing. And this is also very important for the exam. So CORS defines a way for client web applications that are loaded in one domain. Let's say your domain, and let's call this, for example, AWS.ie. Once the user inside your page click on an external domain or a different domain, let's say Facebook.com, if CORS not enabled, that kind of action will be blocked. But in SC3, you can allow this kind of behavior, which is the CORS, and once you allow it at the client-side web application of your SC3, this will allow cross-origin access to your Amazon SC3 resources. Now, how you would do that in a specific bucket? Normally, CORS configure as an XML document with a specific rules that basically identify the following: the origins that you will allow to access your bucket, the operations, whether HTTP methods that will support for each origin. In this example, we have put, post, and delete are allowed for going to a domain called www.example.com, which could be configured using Amazon Route 53 to be another SC3 bucket, for example. And the last object is operation-specific information. Now, why we sometimes need to refer from an SC3 bucket to another SC3 bucket in order to cover two domains. For example, example.com in your domain name system should be a record, and www.example.com is another record. So most likely you will end up creating two buckets to cover both. One contains the actual website, and the other you only use it with CORS referring and configuration just to point to the www.example.com. And let us now understand how we can host a static website using the guided lab of Module 3. In this lab, we are going to create a bucket in Amazon SC3. We will upload a sample content to that bucket, and we will enable access to the object, and we update the website. We have multiple use cases beside hosting a static website, and the third use case is to use SC3 bucket for storing data for computation and analysis. And most likely this will come with machine learning and big data. So those large-scale analytics projects such as financial transaction, clickstream analysis, media transcoding, Amazon SC3 can support this workload because of its ability to horizontally scale and enabling multiple concurrent transactions. So for example, the diagram here is showing us an Amazon Elastic Compute Cloud EC2 Spot fleet, and those are basically created when the bid price for the Spot instances is low, or when an Amazon EMR cluster, Elastic MapReduce cluster, is spun up. After the compute capacity is available, the raw and processed data is extracted from Amazon SC3 and also from another data source. So the data is run through compute algorithms that integrate and transform it. The result will be a processed data that will be loaded into different Amazon SC3 buckets. In this case, the data has been processed and the compute capacity is terminated to save one cost. Finally, an analytics tool such as Amazon QuickSight might be used to harvest meaningful insights from the processed data. So this is just only one simple scenario how you can employ Amazon SC3 in a big data and machine learning project. You could also use it for backup and archiving of critical data. And this is very important also to understand, because SC3 is highly durable and scalable. It could work very good for data backup and archiving tool. In this scenario here, data is backed up from one on-premise data center and also from a large number of Amazon EC2 instances running in AWS. You can move long-term data from Amazon S3 standard storage to S3 Glacier. The process we will discuss now when we study Glacier, but in fact, this will give you a reduced cost for those objects, and S3 will be able to move your data based on the usage pattern. So you could specify to move your data to Glacier, which is an archiving solution, after 30 days or 60 days or 90 days. If those data are not accessed. Another Amazon S3 object that you can configure, guys, is to achieve higher level of durability is a cross-region replication. And the cross-region application will allow you to basically copy the content of all modified objects. Pay attention to this, guys. All modified objects, you copy those modified, updated, deleted objects to a replica in another S3 bucket in another region. Objects that are uploaded to the bucket in one region will be automatically copied to another S3 bucket in that other region. And lastly, what is the data consistency model in Amazon S3? And seriously, this is very important for you to keep in your mind before the exam. Amazon S3 provides us with read after write consistency for pods and all new objects. So any new object upload to S3, you will read it after you write it. So imagine the same object, there is two persons, one writing to that object and one reading from that object. In this case, the previous version of the object will be retrieved. The second option is eventual consistency for overwrite, pods and delete in all regions. So that applies for all existing objects, not a new object. In this case, if somebody trying to read the file and somebody is trying to write to the file, in this case, the write operation go first and then the read. So if you put to an existing key, a subsequent read might retain the old or stale data or backdated data. Amazon S3 achieves high availability by replicating data across multiple servers within the data center. So if there is a POT request and it is a successful request, your data will be safely stored. The information about these changes must replicate across multiple Amazon facilities, which might take time. So the process to write a new object to Amazon S3 and immediately list the keys in that object until the change is fully propagated, the object might not appear in the list. But if you have a process replaces an existing object and immediately try to read it until the change is fully propagated, Amazon S3 will give you the previous data. If the process deletes an existing object and immediately try to read it until that process of deletion is completely and fully propagated, Amazon S3 might retain the deleted data. So you see the difference? You need to pay attention to that. So in summary, S3 has two consistency models. Read after write for a new object and pods as well. Also, it gives you eventual consistency for overwrite. So if you delete the object, most likely somebody trying to read it, he might get the deleted content. So a process deletes an existing object and immediately lists keys in its buckets until the deletion is fully propagated. Amazon S3 list also those deleted objects. Now, how about storing data in Amazon S3? As we said, Amazon S3 has multiple classes, and the first class is the S3 standard, which is for frequently accessed data. You could also move your data from the standard one to Amazon S3 standard infrequently accessed class. With the standard infrequent access, guys, it's offer you all the benefits of Amazon S3 standard, but it runs on a different cost model to store the infrequently accessed data, such as an old digital images or older log files. This will give you a 3-day minimum storage fee applied to any data placed in the S3 standard IA. Another class from this is called the Amazon S3 One Zone Infrequently Accessed Data. In this particular class, it is suited the customer who want a lower cost option and who do not need the availability and the resilience of the S3 standard or S3 standard infrequent access. So you need to pay attention to that. If you use this with your disaster recovery plan, you need to pay attention. If you are moving your data backup to S3 One Zone Infrequent Access, remember, this is going to give you a cheaper cost model, but at the same time is not guarantee if the whole zone is not available and you need to recover and restore your data. Maybe your data is not available. So you have to be careful whether you need to use one zone or a standard infrequent access multi-zone. For the exam also they refer to SC3 standard IA or infrequent access, sometimes with multi-zone, just to distinguish this that this is not one zone. Now about the intelligent tiering, this is designed to optimize the cost by automatically looking to your usage pattern from the SC3 standard and moving your data to a lower cost model, which is the intelligent tiering. This is very good for smoothly monthly monitoring and automation fee per object. This is basically will give you a good access pattern, and at the same time you will be able to retrieve your object, and they also have a better durability. Also we have something called Amazon S3 Glacier or deep archiving. Now remember, this is S3 class which is designed mainly for data archiving. You can store any amount of data at costs that are competitive. And to keep your cost low, you can also move those data from S3 Glacier to S3 Glacier Deep Archive, which is another lower class of storage. You can look at it as a cold storage. At the same time, when you put your archiving solution in a Glacier, you have 3 different retrieval models to reduce the cost. You have the expedite retrieval, which make the object available to you in 1 to 5 minutes. You also have the standard retrieval, which an object retrieve maybe take between 3 to 5 hours. And you have finally the bulk retrieve, which can complete within 5 to 12 hours. In general, Amazon Glacier Deep Archive is the lowest cost storage class in Amazon S3. It's more suited for long-term retention and digital preservation. However, the data is stored across at least 3 geographically distant availability zones, and they are protected by 11 nines of durability, and the object can be restored within 12 hours. So remember guys, in S3 Glacier we have expedite, standard and bulk. In Deep Archive we can get the object in 12 hours. It is the lowest and the cheapest. And let us look now to something called the Amazon S3 Lifecycle Policy. In Lifecycle Policy, you can control how your object will be moved from a class to another. You define a rule, and that rule will take action over the data. So for example, you want to move all the objects that you don't access in the last 30 days from S3 standard to Amazon S3 standard infrequent access. And then you want to move the object from Amazon S3 standard infrequent access. After 60 days, you want to move them to Amazon S3 Glacier, and then you want to delete them completely after 365 days. Now, what is the cost model in Amazon S3? Now, with Amazon S3, you pay only for what you use, and there is no minimum fee. There is 4 cost components that you need to consider when you want to use Amazon S3 storage classes. So you pay per gigabyte for the all object that you store per month. And each class of object or storage class has its own pricing model per region. So from one region to another, the cost could be different. Now, when you transfer the data from S3 to the internet, you need to pay for all copy, post, list, get, and select, and the life cycle transaction, including data that when you move the data from one class to another, and also data retrieval request. When you request to retrieve your data from a Glacier, you also need to pay. However, there is no charge when you put your data in. When you want to transfer the content of the bucket from Amazon S3 to CloudFront or to another service in the same region. And there is no charge as well for any delete and cancel request. So when you delete an object or you cancel the upload of an object, there is no charge. So keep this in your mind. Now, before I forget, guys, also you need to pay if you transfer the content from SC3 to another SC3 in another region, you have to pay. So to move data from Amazon SC3 to another parts, you can use the management console, and we will see this now in the demo, or you could use the command line interface similar to what we see here in the screen. You can use the command AWS SC3 copy test.txt, and will be copied to SC3, the name of the bucket, / also the name of the object, because you have to specify this name, because this is basically the key for the object, and this is how it will be stored physically in SC3. You could also use third-party tool or AWS tools and SDK to uploading large object, as we will see, like Multipart uploads, accelerated transfer. You can also upload multi-part of the objects, especially when you have a large object. We said in SC3, a single object could be 4 terabytes. In this case, you can upload it all at once, but this will never happen using a drag and drop to the web interface. So you have to use a tool or a third-party tool or the Amazon, and you can have the ability to pause and resume also. Similar to any cloud storage tool that we use normally, you can pause and resume at any time, and it gives you an improved throughput. However, there is something called Amazon SC3 Transfer Acceleration, which is a better tool to speed up the upload, and will deal with your bucket via enabling and fast and easy data transfer URL, which makes it available in the edge locations of a CloudFront, and will be globally distributed. So the data, once it's uploaded to the SC3 Transfer Acceleration, it will be routed to Amazon SC3 over an optimized network path. Now, when you can use Amazon SC3 Transfer Acceleration, when you have customers all around the globe and you want to upload locally or centrally from multiple customers distributed in multiple countries. When you want to transfer gigabytes of data or terabytes of data across continents in a regular basis. And when you have, for example, a very bad bandwidth and you want to upload files to Amazon S3 over the internet, then it is much better for you to use the Amazon S3 Transfer Acceleration, which I will show you now in the next demo. Now, lastly, sometimes you want to migrate to the cloud and you have a large object in petabyte scale data. In this case, you can use a service. It's called AWS Snowball. Snowball is a data transport option that does not require you to write any code or to purchase any hardware to transfer your data to Amazon S3. All you need to do is to create a job in the AWS Management Console and a Snowball will be shipped to you. So there is a physical hardware that will be shipped to your data center, to your office, and you will put the data in it, and then you put it back and you ship it back to Amazon. So all you need to do is to attach it to your local network and transfer the file directly into it, and then you ship it back to your AWS closest region or to the nearest Amazon facility, and the data will be transferred into your AWS account. If you have large amount of data, what you can get is a Snowmobile, even larger than the previous one, which is the Snowball. In a Snowmobile, it is a data transfer option that operates in exabyte scale. An exabyte is a 1 million terabyte or 1 billion gigabyte. It should only be used to move extremely large amount of data into AWS. A Snowmobile is a 45-foot long shipped container that will come to you in a semi-trailer truck, and you can transfer 100 petabyte of data per Snowmobile. So if you order this feature or this service to your on-premise data center, it will use multi-layer of security designed to protect your data, include as well dedicated security personnel, GPS tracking, alarm monitoring, and 24/7 video, and also an optional security escort, a data encryption with 256-bit encryption key, and you could also use AWS KMS keys to encrypt the data, and it is designed to ensure both security and full chain of custody over your data. So the last thing for today, guys, is choosing a region. And we discussed this before. So just to make sure we understand how we can select the best region for our application. So first, you should consider data privacy law and your regulation and compliance requirement. Data you store in AWS is subject to the law of the country and the locality where it is stored. Second, the proximity to your customer base and the latency, which is a very good and crucial factor for your business. The latency difference between using closest region and the farthest region is very small, but even a small difference in latency you can impact in your customer experience. Also, the availability of service in that region and the cost effectiveness, because costs vary between regions. So for example, a T2 medium will cost in the Irish region 2 cents per hour, but in the Frankfurt region it will cost 1.5 cents per hour. So the last thing we want to do to understand SC3 is the challenge lab for creating a static website for our cafe. So they mentioned that they want to create a website, should also provide customers with business details, the location of the store, the business hours, and the telephone number. And they want to create this first website for the cafe. You will take the role of Nikki in this activity and work to produce the result that everyone back at the cafe hopes you can deliver. So the tasks are very similar to the guided lab, but here you will be given a code that you need to extract it. You create a S3 bucket to host your static website. You upload the content to it, and you create a bucket policy to grant public read access. And then you need to enable versioning on that S3 bucket, and you need to set up a lifecycle policy, and you will enable as well a cross-region replication. So the final product of the lab will look like this. You will have the cafe website served from one Amazon S3 bucket, and the data will be replicated to another S3 bucket. Thank you for seeing this class, which is adding a storage layer for the cafe.